Hello everyone, welcome back to the course. My name is Joshua Dara, and in today's session, we are going to learn one of the most important tools in data analysis and machine learning, that is NumPy. If you want to become a data analyst, data scientist, AI engineer, or even work with scientific computing in Python, NumPy is absolutely something you must understand. In this session, I will teach you what NumPy is, why it is so powerful, how arrays work, some of the mathematical operations, indexing and slicing, statistical functions, and we'll even do some live coding together. This is section 3 of our data analysis series, and today is beginner friendly, so even if you've never touched NumPy before, don't worry, I'll guide you step by step. Make sure you like the video, subscribe at least to the channel, and let's get started. So now, what exactly do we mean by NumPy, or what is NumPy? NumPy stands for numerical Python. It stands for numerical Python. It is a Python library used for working with numbers, performing mathematical operations, handling arrays, and processing large data sets very efficiently. Now you might ask, Joshua, why can't we just use Python lists? Fine, that is a good question. The answer is NumPy arrays are much faster and more memory efficient than normal Python lists. In real-world data analysis and machine learning, these data sets can contain thousands, millions, or even billions of values. Using plain Python lists becomes slow. NumPy solves that problem. That's why almost every major Python data library depends on NumPy internally. That is Pandas, scikit-learn, TensorFlow, PyTorch, and many more. So if you understand NumPy, you are building the foundation for the entire data science ecosystem. Now, let me show you guys how we can install NumPy in our terminal. To get started with the installation, simply open your terminal. This is already using VS Code. You can open the terminal in VS Code, or just open your command prompt, any of them, or Windows PowerShell, or just any terminal you have on your Windows or your laptop to open. Now, when you open it, when you open your terminal, type pip install, then you type NumPy. That is the package we want to install. When you type it, you hit enter. It will start the installation process. Let's wait for a while. Yeah, now requirements already satisfied because I already have NumPy installed on my PC. So when you are done with the installation, or those that are using, if you are using Jupyter Notebook, or Google Colab or Anaconda, for instance, NumPy may already been installed on it. So you just, to test it, open it and type, just open any Python file and type import NumPy as np, or just anything you want to import it as. If you don't get any error typing this, it means your NumPy is working properly, or it has been installed on your PC. Now let's talk about this np part. You'll notice almost everyone writes import NumPy as np. This is called an alias. Instead of writing NumPy array, we simply write np.array instead. This saves time and makes code cleaner. So we are just importing, it's like we are assigning this name to our NumPy that is being imported. So instead of writing this entire NumPy, if we want to use NumPy, we just simply type np in place of NumPy, and we use. Now let's create our very first NumPy array. So type this with me. Since we've already imported NumPy, you type import NumPy as np, then let's give a variable and assign it this NumPy array. It should be arrays of some integers. So let's say 1 to 5. Now let's try printing that variable a. Now when you run this, you see this printed here, the array being printed as 1 2 3 4 5. So you've just created a NumPy array. It is as simple as that. You just created a NumPy array. Now notice something interesting. There are no commas in the output. Meanwhile, we place commas here, but there are no commas in the output here. That's because NumPy arrays are not regular Python lists. Arrays are optimized data structures designed for fast numerical computation. Now let's compare Python lists. This Python list 1 2 3 to a NumPy array 1 2 3. These two. Is just an output I'm writing for you guys to see. They are very similar in appearance, but completely different internally. As in when these things are outputted, they are very similar in appearance, but they are completely different internally. So why exactly is NumPy faster? There are 3 main reasons. So let's take the first reason. Continuous memory storage. NumPy stores value close together in memory. Fixed data types. That is the second reason why. NumPy is faster. It deals with fixed data types. All elements usually share the same type in NumPy arrays. So why exactly is NumPy faster? Let me give 3 main reasons. One is continuous memory storage. NumPy stores values close together in memory. The second is fixed data types. All elements usually share the same type. The third is vectorized operations. So operations happen internally in optimized C code instead of slow Python loops. This makes NumPy extremely fast for, say, mathematics, machine learning, simulations, statistics, and large-scale computations. In fact, NumPy can be dozens of times faster than Python lists. Now let's create different types of arrays. First, a one-dimensional array. So to create a one-dimensional array, as we already typed here, let me spell this out so that you guys can see. This already that we've created is a one-dimensional array. Let's say a 1D array. Now let's create a 2D array, that is two-dimensional array. And let's assign that one m being equal to np.array. Now let's give it our first to, let's say 3 or 4. So now this is okay. Let's send this print here, and also bring in another print here to print the next array that we've created. Sorry if you cannot see one. So now this first one, it's a one-dimensional array, and this second one is a two-dimensional array. Now let's run the code and see the output so that you guys understand what's going on. You will see that the first one, it is just printed in one single line, and the second one looks like a table or matrix. It looks like a table of matrix. Now, 2D arrays are extremely common in data sets, images, spreadsheets, and machine learning. For example, an image itself is basically a giant matrix of pixel values. Yeah. Now, let's inspect the shape of an array. As we've created this 2D array, let's inspect the shape by the array.shape. If we type this array.shape and we run it, let's run it again and see. Sorry. Now, let's inspect the shape of an array. To inspect the shape of an array, simply type the array's shape you want to inspect, and then add. Okay, so let's repeat this one here, so that we can print everything separately. Then we right print the array we want to inspect the shape of, then we add dot shape to it. So if you run this code, we are going to see the first one-dimensional array, the two-dimensional array, which is in a table form or in a matrix form. Then we see the shape. So you see that this is a 2x2 matrix form. It is in a 2x2 matrix format. This means this two-dimensional array has 2 rows and 2 columns. Now let's try another example. Let's give another variable x, and let's say we assign an array to it, and the array consists of 1, 2, 3. That should be fine. This also consists of 4, 5, 6. And let's try to output this and see. Okay, yeah, let's try to output this. For now, I'm coming. Let me print something here so that we can now identify or distinguish between what is going on. Just a moment. Yeah. So now let's come to let's come back. So let's output this. We print our x first. We print whatever we have in the array. Then we print the shape of that array. Yeah. Let me send this to the top so that it doesn't confuse it. If we run this again, you see the second example that we've done here, this array here. You see its output here, and you see that it has, the output has two rows, which is this one and this one, which is here. The first one is the row, then 3 columns, which is this, and this. So 2 rows, 3 columns. This is the shape of the array. Understanding shape is very important in machine learning and deep learning, so you should take note of it. Now, let's perform some mathematical operations. So let's create 2 arrays. Let me comment these ones out for now. Let's create 2 arrays. So let's see, our first array, we should assign it to the variable a, and it should be just a 1-dimensional array. And the second one, we should assign it to b. It should also be a one-dimensional array of say 4, 5, 6. Now let's do some operations with them. Let's try adding them and see. This is the addition. Let's see A plus B. If we add this, so let's say we print this A plus B. Let's see what the result will be. Now the output is 579. Notice the addition happens element by element. Now, before I come back to explain this, let's do some subtraction and see. And this name is up, so that I move on quickly. Let's do another subtraction and run this also and see. So now this is our addition, this is our subtraction. You realize that let's take the addition for instance, it happens element by element. So it took 1 plus the first element plus the first element in the second array, the second element plus the second element in the second array, the third plus the third. That is how it happens. That's the same thing for the subtraction, that is the same thing for the multiplication, that is the same thing for the division. This is called element-wise operation, and this is one of NumPy's superpowers. Normally in Python you would need loops for this, but NumPy handles it automatically, so you wouldn't have to write any loops just to achieve this simple addition or these simple numerical operations. Now let's learn something very powerful called broadcasting. Now broadcasting allows NumPy to perform operations between arrays of different sizes. Let me come again. Broadcasting, it allows NumPy to perform operations between arrays of different sizes. Example, let's take this first array over here, which is the one assigned to the variable A, and add 10 to it. So let's come to this place. Instead of A plus B, let's make it A plus 10. Let's output this and see. Now NumPy automatically adds 10 to every element. Added 10 to 1, added 10 to 2, added 10 to 3, which gives us 11, 12, and 13 in the output here. For this, no loop is needed. That is one of the superpowers also of NumPy. So this may look simple now, but broadcasting becomes extremely useful when working with large data sets and machine learning models. So you should also take good note of this also. Now let's access specific values in the arrays, taking the first array we've created. Remember, Python indexing starts at 0. Right now we are coming to talk about indexing. Python indexing starts at 0. So to access specific values in this array, we need to use the indexes of the values. So if I want to access the first value in the array A, I need the index of that first value, and index of a first value is 0. So to access that, we do the array, which is the one we've assigned to the variable A. We do it and we put it in this square brackets. We put the index in the square bracket as 0. That means you're accessing the first value in the array. So this one is like, let me give it here so that you see. We have, this is the first index, this is the second, this is the third. Though it is a third, it is still index 2. Though is the second, is still index 1. Though is the first, is still index 0. So take note of that. So we want to access 1. So meaning we have to write print the variable we've assigned to the array, then the index of the array we want to access. If you print this, you see that 1 has been printed. So let's assume you want to access 3 in this array. So we just did, we write index 2 since it is the one corresponding to 3. Then we see 3 printed here. Negative indexing also works. So let's say we do -1, negative index of 1. You see 3 has been printed because we are going backwards. Yeah, going backwards. Yeah, going backwards. Yeah, which is the last element. If you use -1, it means you are going backwards to the last element. Now let's go ahead and talk about or learn about slicing. Slicing lets us extract parts of an array. Example, we are still on this array. Let me remove this one for now. We are still on our array here, but let's add some to it. Let's add some numbers to it. Let's add 4 and 5 to it at least. Now let me write something for you guys to see. I write this and I write 1 to 4. When I print this, wait, let me, I think this place is clumsy. Let me clear it and print it again for you to see. Now when I run this, you see this being outputted and you see 2 3 4, which is 2 3 4. So what I basically did is slicing. That is just what slicing is all about. Now let me explain. So I'm telling Python to print from the first index, which is 1, till it meets 4. That is why it printed 2 3 and 4. The ending index is not included, man. Let's skip this element and let's skip this element and see. So let's say I type, type this. If I output this, it means I've skipped the number. From the output you can see that a number has been skipped in the array, which is 2. Use these double columns to skip a value. So I'm skipping this value here, which is 2, the value 2 in this array. So you see it started 1, 3 and 5. This means take every second element. This means take every second element. Now let's reverse this and see. When you run this also, we see its output here. This is very powerful. You can see the output here too. So slicing in NumPy or in Python, it is a very powerful method too. Now let's talk about 2D indexing. Let's see how we can access rows and columns in 2D arrays. We've been talking about one-dimensional arrays for a time now. Let's move on to 2-dimensional arrays. So now let's turn this into a 2-dimensional array. Let's turn A into a 2-dimensional array. Let me take this one off for now. This is okay. So to access the first row, let's print it so that we can see. To access the first row, we simply type the array and we give it the first row, which is the first row. Now we are accessing the first row, which in this array we can say this is the first index and everything inside. That is what the code is saying. So if we print this, oh sorry, I forgot some of the brackets. Yeah, let's run it again and see. Yeah, so you see it prints the first row and everything inside. First row, which is at index 0 of this array, and everything inside. Now to access the second column, we do it in a reversed way. So this comes first. This array has two indexes, which is index 0 and index 1. So the 0 is the first one, 1 is the second one. So to access the second column, we write 1 instead of 0 because we are trying to access the second column. So if you write this and you print it, you would see your result. You see 2 and 4. We are accessing the first column. We are accessing the first column, which is this 2 and 4. The column means select everything. So when you just see column, it means select everything. This is very important for datasets where columns represent features. Now, let's talk about statistical functions. Let me explain what statistical functions are. But before that, let's explore some built-in statistical functions, some of which are, let me give an example. The word statistical function already explains itself. It's just functions used statistically. So mean statistics, standard deviation statistics, sum statistics, most of them. So this is for me. For standard deviation, we use STD, that is standard deviation. For sum, we just use sum, and a whole lot. These are just some of them. So to use, you just write this and add your brackets to it because they are functions. Let's use one of them and see. Let's use the mean. So let's say we want to know the mean of A, or we want to find the mean of the two-dimensional array over there. So we print. Let's print the mean of the two-dimensional array here and see the result. We see the results as 2.5. That is the mean of this two-dimensional array here. We can try for the rest, like the standard deviation, the sum, and let's try for sum again and see. You see the sum to be 10. You can try for the standard deviation to try for the standard deviation. You see it to be 1.1180, and it continues over here. These functions are heavily used in data analysis, machine learning, statistics, finances, and scientific research. So for now, I would like for us to do a mini challenge. But before that, let's look at something. Let's do a quick challenge together. I want you to create an array of random numbers. So to create an array of random numbers, just simply type random. Let's give it a variable, random arrays. So we type np dot. Now this creates 20. This would have just written creates 20 random integers between 1 to 100. Now let's compute the mean, the median, the standard deviation, and the maximum value. You can try it yourself before looking at my solution. So you can just pause, try it, then look at my solution. Now my solution is very simple. Just type np.mean, then your variable. Same thing goes for the median, then your variable. Same thing goes for all of them. Standard deviation, your variable, and also the max and your variable. Excellent. This is exactly the kind of operation data analysis or data analysts perform daily. So you can go ahead and and print all this to see the results. And this is just a simple task. You can just go ahead and print all this to see the results. Now, let's talk about where NumPy is used in the real world. It is used almost everywhere. Examples include artificial intelligence, machine learning, financial analysis. Now, let's talk about real-world applications of NumPy. So, where is NumPy used in the real world? It is used almost everywhere. Examples include artificial intelligence, machine learning, financial analysis, data science, robotics, computer vision, scientific simulations, engineering, and weather forecasting also. Whenever you hear about AI systems processing massive amounts of numbers, NumPy is usually somewhere underneath. Let me also show you some of the common beginner mistakes that most of the beginners do. One mistake is forgetting to import NumPy. As you've seen before, I would write this. I went to import NumPy again as NP before I started writing, or before I started using it. Now, mistake 2, mixing array shapes incorrectly. Some operations require matching shapes. Another mistake is confusing Python lists with NumPy arrays. They look similar, but they behave differently. Mistake 4 is forgetting that indexing starts at 0. Maybe you want to access the first element and you went to type index 1 instead of index 0. Indexing starts at 0, not 1. Yeah. Let's summarize what we've learned today. Today we covered what NumPy is, why NumPy is fast. We've covered creating of arrays, one-dimensional arrays and two-dimensional arrays. We've covered some mathematical operations that can be done with that. We've covered what broadcasting is, what indexing and slicing in is, what statistical functions are, and we've also talked about some real-world applications. NumPy is one of the most important foundations in all of Python data science. Master this well, because everything we learn next will build on top of it. Now there's an assignment here for you. Just create a one-dimensional array of 20 random integers, then compute the mean, the median, the standard deviation, and the maximum value for it. The second assignment is you create a 3x3 matrix. You perform element-wise addition and matrix multiplication on it. Now the third assignment is create an array of 50 values. Extract every other element, then reverse the result. That is the third assignment. That brings us to the end of section 3 on NumPy basics. I hope you enjoyed this lesson and learned something valuable. In the next sessions, we'll move into pandas and data wrangling, where we'll start working with real data sets like professionals. So if you've enjoyed this video, you can like, share, subscribe, and turn on notifications so that you don't miss the coming or next session. Thank you so much for watching. My name once again is Joshua Dara, and I'll see you in the next class. Bye.